Hi, I'm Hannah, and in this video I'm going to be showing off Toolbag 4's most anticipated and exciting new feature, the ray tracing. I'll be going over the raster rendering mode as well, which will cover a lot of existing features from previous Toolbag versions, plus some additional features we've added to this system. We recommend you watch our short videos on Toolbag's new interfaces and workspaces prior to this one, as I will be navigating through some UI elements that might be unfamiliar to new users. For those completely new to ray tracing, let me briefly explain. Ray tracing is a rendering technique that produces incredibly realistic lighting and can produce very believable scenes. As graphics cards capable of supporting ray tracing are hitting the market, it's becoming more of a viable solution for 3D artists worldwide. We hope that our new ray tracing and advanced rendering systems can aid artists in creating visually stunning and high-fidelity scenes with their artwork. When first opening up Toolbag 4, the viewports will be using raster rendering, which is quicker for setting up your scene and iterating. For this demo, we're going to be working in the rendering workspace, but it's worth noting that ray tracing can be applied and viewed in any workspace or viewport so long as they're set to full quality. The rendering workspace is useful to work in when you're preparing your final shots, as the secondary viewport in the bottom half allows you to tweak and iterate your compositions and lighting without ruining the positioning of your cameras. You can, of course, pop this second viewport out and have it floating off screen if you want more space to work in the main viewport. To enable ray tracing, you will first have to open up the render options. To do this, either select the green cog in the scene hierarchy, or navigate to the render menu up at the top here and select Render Options. The Render Options is where all settings relating to your render outputs will live. Turning on ray tracing is as simple as ticking this checkbox. Any viewport set to full quality will now use ray tracing as their rendering mode. So already this looks great, but there is a few settings here that we can adjust to achieve certain effects and improve the fidelity in our shots. First up is the bounce count. Ray tracing works by bouncing light rays off surfaces towards the sources of light. Just like in baked lighting or with global illumination, increasing the amount of bounces will improve the fidelity and quality of the image by adding bounced diffuse lighting and accurate reflections. Naturally though, this does come with a performance cost, and the more bounces you put in, the longer the lighting calculations. 3 bounces is usually a good amount. Any higher than this and you'll start to see diminishing returns in the end result. The second counter is the transmission bounces. Transmission rays are involved with refraction, and so you're going to want to bump this up if you're working with glass or other transparent objects in your scene. If you're working with assets that use multiple layers of transparent materials, for example water or whiskey in a glass, you're going to want to increase the transmission amount up a fair bit in order to allow the refraction rays to travel through all of the surfaces. Caustics are an integral part to working with highly reflective or transparent materials, or for things like gems. They're the patterns of light you see when light shines through a glass or liquid, or, for example, at the bottom of a swimming pool. To enable these, ensure that the Allow Caustic Paths checkbox is ticked. You can see there's now more defined contact reflections on the ground from where the light shines through the diamonds and the whiskey. Diffuse and reflection intensity sliders are here for adjusting the intensity of the secondary diffuse and reflection bounces. These can give you finer control over the global illumination of the scene, and this is great for fine-tuning shots or working with stylized art. But please note that care should be taken when adjusting these, as too high or too low a value can create some unrealistic effects. The radiance clamp will limit the amount of brightness from a light source, which can help mitigate noisy, super bright pixels, otherwise known as fireflies, from your images. By default this is set to 50, but it's worth tinkering with on a per shot basis to balance out the sharp highlights in your renders. Underneath the initial ray tracing settings are a bunch of viewport-specific parameters. These settings only apply to what you're seeing in the viewport and will not have any effect on any of the outputted renders. First of all, you can set your samples and rays per pixel. The samples are used to progressively improve the viewport quality by accumulating frames over time. As for the rays per pixel, rays are responsible for calculating the color of a pixel, and so increasing the amount of rays being sent out by the renderer will improve image fidelity. This will, however, have a slight knock-on effect on the viewport's frame rate. Below this is a slider for setting the strength of your denoising. Denoising uses an algorithm to remove graininess and noise from your renders, and will have more of a noticeable benefit on renders that are using less samples. You can disable it completely by setting it to 0, or you can have it set to a high value if you're wanting to work quickly in the viewport with a low sample count. High denoising strengths can crush details out of an image, especially in textures, so it's recommended to reserve those for previews. The raster rendering section is included in Toolbag 4 for users who don't want to use the ray tracing system, or for existing users who wish to use the legacy settings. First up is the shadow quality. This can be switched between low, high, and mega in this drop-down menu. There's also the option to use cascades here. Cascades are useful for when you're working with directional lights and find that you're encountering some pixelation or aliasing in the shadows that are nearest to the camera. Screen space occlusion is still an option in Toolbag 4 as well, though we've added a couple of new configuration options for you to have finer control over the look of your shots. In previous Toolbag versions, the AO would only apply to the ambient skylighting, which would be this first checkbox here. But now you can apply it to the diffuse and specular as well. Additionally, and I think this will be great for anyone who's working with stylized art, you can now set the color of the ambient occlusion. You can set the strength of your AO and its distance with these two sliders. The higher the setting, the more stylized and extreme the effect. Underneath the AO settings are the parameters for reflections. Enabling local reflections can work to improve the quality of reflective surfaces by approximating reflections between objects. This works pretty much the same as previous Toolbag versions, though we've now implemented a slider to give you more control over their appearance. Finally, the local diffuse setting will add a kind of screen space global illumination. While not technically GI, it will boost your ambient diffuse reflections to simulate more bounced light between objects. Like with the AO, you can adjust the strength, but you can also adjust the distance of the effect, which changes how far from objects the renderer will search for diffuse bounces. The render output is where you'll specify your image and video output settings. These used to live in the capture settings in previous Toolbag versions, but we've now combined them all inside this handy entity. You can set your output path, the resolution, and the file format of both image and video outputs. You will see that in both the image and video export settings, there's options to set your denoising strength and to set the sampling amounts also. As mentioned earlier, these are separate to your viewport settings, and it's these parameters in particular that determine the quality of your final renders. You have the choice here to have your export sampling settings match your viewport for better visual representation of the final result. Or you can choose to go with low samples and high denoising in the viewport for fast working times, but keep high sampling values and denoising low or disabled for the final renders. Overall, for the best quality renders, you want to go with as many samples and rays as you can afford. and a fairly low denoising strength in order to preserve fine details and texture definition. The video output also has an extra slider for compression quality. This dictates the compression quality of any outputs using compressed file formats, such as JPEGs or MPEG 4 videos, and this shouldn't be confused with a global quality setting. So that brings us to the end of this video on ray tracing and raster rendering. There's a lot more to learn about ray tracing and how it interacts with some of our new shaders, so I highly recommend giving our Intro to Shaders video a watch right after this one. This will go over things like subsurface scattering, transparent materials, and clear coat reflections. As always, we look forward to seeing what you create with these brand new features, and we hope that you have fun doing so. Thanks for watching, and have a great day.